Hey guys, so today's Leak Code Daily Challenge I was not able to do. It was quite tough for me, and I just kind of want to walk. It was like it's not obviously it's not practical that I could do every single problem every day, but for the days that I miss out, I want to at least come back to it and kind of think about what went wrong and just like analyze. Like I guess this is an analysis and talk about my thought process. So like reading the question, length of longest Fibonacci sequence, when I saw Fibonacci, it was kind of like a alert, oh, maybe we have to use some sort of like dynamic programming. But then what was tough is kind of, well, to be honest, like, so the answer to this is they used a two-dimensional, like 2D DP array. And I don't have a lot of experience with that, so that's not something I even considered. I only considered like a one-dimensional, and that got really confusing really quickly. Um, yeah, it was like I didn't know how to keep track of things in the past, especially because like multiple multiple subsequences, the like sorry, multiple values could be used in different subsequences. Like for this example down here, like the 11 appears in all these answers. So in my head back then, right, it's like how do we keep track of 11? Which subsequence is it part of? Because we don't know. It might be part of the 1 in 11 is the best one, or the 3 in 11 is the best, or 7 in 11. So yeah, that was tough for me. And then then I strayed away from DP and ended up going trying to use like caching and memoization. And it was kind of funny because like I kind of liked the code that I put. I put some time into this, but it was obviously bad. And since I couldn't do DP, I was like, okay, maybe I could like cache a function. And I created a function that takes in the current index, the current count, and the last two in the result, like the last two things, right? Because the whole question is whether the array we're at right now, can we take the last two things and add them together? So yeah, I just did that with the end case of when the index reaches the end. When the index reaches the end of the array, then I could just return the current count. And then I did that thing where it's like we either take or no take, but it was a little bit tricky because we can use the current array if the previous and the previous summed up to the current element, right? And if that was the case, then we could up the current count and then we can just pass in the current and one back. And that's what I did there. But then what it got confusing was what happens when that's not the case. We have to either not take it, which means we just keep the previous and the previous. We keep the current count because we're not adding to our result. And then we just up the index. So that made sense as well. But then this was hard. It's like, so now maybe we need to restart the the subsequence, and I didn't know what to do there. Like I was thinking if we restart, that means we forget about everything previously and we just have a length of 2 with p and the current array. But then I didn't know whether it would be previous in the current array or it could be many things before that, right? Like this array could have been like I minus 3 or I minus 4. So I was stuck. And then after that, I pretty much just looked at the solution. And what ended up working was a 2D dynamic programming. So I don't really do 2D dynamic programming problems, and I need to practice that. And the only times where doing that, I have like practice doing that is when they literally give you the grid, right? Like those maze problems or like those robot problems where it's like, how many different ways can the robot go from top to get to the bottom right or something like that. But in this case, we treat the two dimensions as indices in the array, right? Because we want the last two. And this last two indices can be many things. Like for this one, it was like the values of those indices were 1 and 11 for the last two, or like 3 and 11. So we want to keep track of this, and we can do this by using an n by n array. Yeah, DP array, where n is the length of the array. So for this like example, when we have 7 things, that means our DP array would be 7 by 7. So it'd be 49 things. And it's gonna have like 0, 0, 0, 1, 0, 2, all the way to 0, 7, then goes down all the way to 7, 7, right? And what previous and cur means is the DP at previous, so the DP at previous and current is like how will give us how many like the length of the subsequence ending at previous cur. And that was kind of hard to wrap around. So like one thing that kind of makes sense is that we loop cur from 0 to n, but then we only loop previous from 0 to cur, right? Because we always want cur to be before, or we always want previous to be before cur. And then we just get the actual numbers. Since cur and previous are indices, we get the actual numbers. Oh, and I forgot to say that we have this like lookup table just for like quick lookups of the value that maps to the index of where it is in the array. So we could have a variable that keeps track of what we want, which is like the number 1 and number 1 minus number 2. And if want is inside of the bank and the want is less than the array of the previous, then we can actually go to DP at that want index with the previous, add 1 to it, and set that equal to our DP of previous cur. So like we're kind of doing that go 2 back to set up the answer for the current one. Otherwise, we will just start over with 2. And now that I think about it, I think I can do 2 right there, and then I could just do this. Let me run that. This should work, actually. Yeah, so that's a little bit cleaner. And what that's saying is that we can guarantee any 2 indices to have a value of 2, right? Because we're using them twice. Like we could just always start there. Yeah. Like if we had if we were at 1 and 4, we can just say 1 and 4 DP of the index. Let's just say they were indexed. The index 1, DP 1 and 4 is just 2 because we're using 1 and we're using 4. And then later on, we'll add to the next thing. If like they ever need 1 and 4. Like if we were at 5 now, and 5 had to look at, if we were at 4 and 5, and then so we do 5 minus 4 and we get 1, we just find where the index of 1 is. Now we can do, okay, what was 1 and 4's value, which was 2? We could plus 1 to that. So now it would be 1, 4, and 5. So that would be 3. And then our max length would be 3. But yeah, even now it's a little bit tricky to me. But yeah, I want to make a quick like just recap of what went wrong. And it's still kind of confusing to me. I still need to like do more of this like 2D DP practice. But yeah, thanks for watching.